Good morning, good afternoon, good evening, depends upon the location from where you're watching this video. And it is truly good to see all of you in this YouTube. My name is Sam and I am a business intelligence developer. So far, with the help of Sam Analytics, we have worked upon the pollution that is actually happening in the ocean and that is creating a menace to all the ocean or the wildlife animals as I am speaking. Well, today is the New Year's Eve and we are seeing the very much that all the plastics are actually dumping in the ocean that is creating a menace to all our wildlife species. Plastic, which is actually came in the 1887 through plastoelastic, a kind of wrapper that can help to carry any substance, has now converting into a global menace and that is slowly consuming the planet into its one single big plastic giant. As you can see from this picture, that is the journey starts of plastics from the both side of the world. Once coming from the Japan and the parts of Russia, and once coming from California, Oregon, and Vancouver, and that is completely this plastic gets submerged inside the ocean, and it is creating a global Pacific garbage patch. So, as we're leaping from 2018 to 2019, it is our responsibility to stop the pollution. But how? Well, I have a solution which is we can use through Power BI. Now in Power BI, I have made a couple of videos which you can see in this YouTube that I have completely worked towards the plastic pollution's negative impacts on wildlife, but I never actually worked upon the higher income countries and the origin of the plastic from basically through the rivers and through the different garbage patch using the higher generation of income from the countries. So how can we actually minimize the sectors and can actually clean our rivers, or how many people are responsible for that particular problem? We will judge through Power BI. So let's just load our data, and once it's been loaded, we can see that we will first take into edit queries. So once we do that, we will directly be taken to the query pane section or the query kitchen, as we all know about it. If we go to Excel sheet, we will be having the plastic and the data is readily available. So we will take one data at a time. Now, as you can see from here, that the plastic waste generation world and plastic production by sector. So we will take these two different data sets to work upon this particular problem. So if I take up the plastic waste generation to the world at first, we can simply load it up, and in here we will simply name as plastic waste generation, keep skipping the world, so that we can get we can skipping the world for our better use of it. And as we save it, this data set is ready to work. Now if I take the Excel sheet and I take the other one, which is plastic production by sector, I will again take the same notion to eliminate the plastic from here, and I'll simply use the production by sector. That will clear and concise my data view or the data sets work upon in the next couple of minutes. So once I close and apply, I can see that this query gets changes in here, but it all begins with the relationships. Now, as I have taken it, the plastic waste generation gets automatically added with this previous data sets, which I actually do not want it. So what I have to do, I have to simply cancel it, and we can take this plastic waste generation in here, and in this part we will take these two tables side by side, and we will make a kind of relationship between these two tables. Once we do it, we can see from here that it is taking bidirectional relationships and it is having the filter for both. This particular way will not work because there is a reason behind it. The up one is the lookup table and the downward is the data table. So the production, the lookup table must flow from the upward to the downwards. So in this way, we will have to take the relationships from many to one, and I will take single-sided filter. So once I do it, it actually comes from many to one. Now if I come up in here and start creating the visuals, I have this particular part, and in here I can see that I have the two data sets newly available in here. Now if I take plastic production by sector, so I will take my matrix in here. In this matrix, I will take in the rows field, I will take basically the nominal part, which is I will take the primary plastics in here, and I will take the values in the entities in here. But it is giving me such a kind of weird numbers in here, and I cannot get the totals of how many primary plastic production actually happened. So what I will do, I will create a measure. For that, I will create a separate table for it, and I will write plastic generation. That is a kind of or generation calculations. I will do that, and I will simply put it on load. Once I do it, it comes in here. Now I will take a new measure, and in this measure what I will do is I will check upon the total plastic production. So total plastic production, I will use the function, which is basically I will take the sum, and in the sum I will only calculate the row, which is plastic production by plastic production by sector. Okay, that is the plastic production by sector, and I will take the production by sector prime plastic millions in tons, and I'll simply lock it up. And if I run through it, I will get my measures down in here. And what I'll do is I will simply take my measure, but after creating this, deleting this column 1. So if I delete it, I get the measure. So if I take this measure into the value section, I will get the total count of the plastic production problems happening in here. So this is quite a kind of mess, and I can check it out through the stacked area chart, and in here you can see this, that the maximum rise is happening at the 400 million in the industrial sectors. That means the industrial sector has to check upon their plastic production and the nuisances that they are creating inside the oceans. Next, I will take another data set, which is basically I will take a new matrix, which is this one, and I will take the primary plastic in the rows section, and I will take the entities into the values. And now what you can see that the maximum the plastics production problems are coming from the machinery, polymer type, electronics devices, additives, and the consumer and the industrial products. Now simultaneously I will create another measure, and in this measure what I will do is I will take the number of plastics waste, which is the number of plastic waste, which will be I will take the count rows, and in this my intention is to use the values so that I can work upon with the implicit measures. So I will take the values, and in here I have to take the plastic waste per capita. So I will take this and I will log this with my first bracket and then the other bracket, and if I take this measure, it will comes down in here. So you can check it out that it is giving me the number of plastic waste as quite one part of it. So now if I take it again, and if I take the number of plastic waste into consideration, I can very well see that this is not the way it should actually work upon, but we have to look upon this way, that this is the real problem right in front of our scenario. If we take another one, which is basically by simply taking another matrix and creating it inside of the same in the rows, and if I take the primary plastic per capita, which is, I will take this one in the rows, and I will take the values in the entity. So this will give me a quite a different part of my graphs in here, that will or that can give me a kind of lookout about the problems happening inside the world, or which are the countries are most responsible for this. And if I check upon in this, we can very well see that the maximized countries are actually situated inside the ocean, and this is what is actually showing the graph in here. And if I go deeper into this data, I can see that Japan and China is equally contributing to plastic pollutions than the rest of the other part of the world. So the production facilities are actually in this part of the world, which is creating more of the plastic pollution for the ocean, that needed to be have a check back onto it. Now if I use a slicer and I take the slicer as per capita for my part, I can very well see that as I increase through it, the number of the sizes gets decreased from here, and that is actually creating a lot of problem. But if I am taking the plastic production by sector and I simply remove it and I take it primary plastic production by sector, you can see that the spikes are very well going to the top, and that is actually creating a lot of challenges and problems to this part of the world. So this was one part where the production sectors were creating a problem. Now I will look upon, or the focus upon, the problems that is happening because of the rivers pollution. That is also our main course of action. In this reverse course of action, what we will do is, we will again have to go back to the edit queries, and in this edit queries we need to reload the data using new sources, and I will take the plastic in here and the data in here, and in this what I will do, I will take the first top 20 rivers in the world. So I will take this data as first, and I do want to rename the table. So I will take basically top 20 rivers, and simultaneously I will take another one that is actually creating the region, or the rivers which are creating a pollution into the region. I will take that into consideration as well, and I will rename the table that plastics or rivers by region. So I will take that in here, and with this I have my two data sets are ready to work with Power BI. Now as my two data sets are ready in here, I have to check upon the relationships, and like I said that I have two different parts are in here. So what I will do, I will take another one, a little bit extent of it, and I will take the river by region and top 20 rivers. Well, I think, and what is my opinion in should be, that the top 20 rivers should be in the data table and rivers by region should be in the lookup table. So if I extend it, I will get in the bidirectional relationships, which is not actually I'm looking out for. So I want many to one, and the data should be single flow. So it will be this time once again, and like this I want it I can bring back my data to the life in here. So let me close all the extended part, and I have my two data sets that actually I want to focus upon, which are river by region, and top 20 rivers are in here. Now, if I take the river by region, I would first consider that top 20 rivers. So if I take my matrix in here and put this one at the top, in very much top in here, and what I'll do is I will take the entity into the rows, and the number of the year it actually happened, and plastic by mass into the values. And if I do it, I can very well say that if I use the area chart, I can get a 0 dot in here. But the moment I take the year into the legend, the whole scenarios will change. If I simply take from count to an average, I can get this particular type of value. Now notice that I have a one singular type of color of graph is here. I can change this using data colors. So I will take a gold as the main or default part, and as well I will take the shape of the stroke width to the maximum so that it can show the gravity of the problem into this particular visuals. Now also I want to take the count of plastic 20 rivers, that which are the main first 20 rivers that is creating the problem. For this I will take another measure which I will take from here, and in this I will write count of plastic 20 rivers, which will be calculate, and this time I will actually remove the filter from which I will remove the implicit measures using the filter conditions through the count rows, wherein I will take the count rows as plastic for top 20 rivers or 20 rivers I can say, or taking that particular table into consideration, I will now deploy the filter function in here, but I need to close this bracket and apply the comma to separate or segregate my tables and columns, and I have to write the filter. In this I do have to use top 20 rivers into consideration, and then I need to apply the measure which is I just have created a couple of time ago, that is the total plastic production, which should be greater than 27, and I will enclose this with the closing bracket and another one like this. So once I do it, I have a measure ready, and if I take a matrix keeping my rows into the plastic mass input and year into the columns, and taking the entity into the values, and here I will actually use the count section, and I will take the newly created measures in here. So you can see that my all measures, all values are equally the same. What if I actually change the 27 is 26? Let's see how this one reacts, this one, and this is the same. So now if I apply for 30, it is still giving me the same thing. That means the problem is with the rivers and the pollutions that is not actually happening from one single country. It is happening for the entire world, and the rivers are contributing to this problem and this and to this particular situation that needs to be taken aware and care for. So we need to understand, we need to work hard through it. And if I take this line and cluster column chart, you can see that it's all coming to the same single part. So I have my two of the visuals are ready, and now if I go to in here and I publish this report, I can simply say that I want to save this report, and once I do it, I can save into ocean pollution by replacing my previous data set. And once I am publishing it, it will go to my Power BI service web server that can be shared to any of the individuals if they want to go for. And once I'm in here, I can check my logins, and if my logins are all correct, it's giving me the visuals access to all part of it. And like that, my visuals are all set, and I can publish it to the web. Because I have no other issues or no other problems to go for it, I can simply take this and use it into my notepad. And likewise, I can share this my Power BI file to the entire world, or whoever wants to have this solution for their ocean pollution. Well, this is all about how I can actually make the world aware of the ocean pollution in Power BI using Power BI. But as you can see that the more whales are getting into kill, and Japan has recently volunteered to kill whales into the ocean. And as 2018 is folding and 2019 is coming up, we must make a pledge that we can save the world if we want to. This is Sam. Wish you a very good and happy new year, and all the best. Bye.